start. Good morning and very warm welcome to all our esteemed dignitaries, distinguished guests, and dear colleagues. I, Avinash Kumar, I am honored to welcome you all to this occasion as we gather for the second day of NCPOR Silver Jubilee and Foundation Day celebrations. It is indeed privilege to stand before such a esteemed gathering of the distinguished dignitaries, respected scientists, and dear colleagues. Today, we continue our journey of reflection, inspiration, and forward looking for the discussion, making the 25 years glorious years of excellence in the polar and ocean research. This milestone is not just a milestone. It's a celebration of our achievement, but also the tribute to the persistent dedication and the contributions for the every individuals who has played the role in shaping the NCPOR legacy. As we commence the today proceedings, I take the privilege to invite our esteemed dignitaries to the dais. I request our former secretaries, Dr. A. Muthunaigam sir, Dr. Harsh Gupta sir, Dr. P.S. Goel sir, Dr. Shailesh Nayak sir, Dr. Rajivan sir, and Dr. Thamban Melot sir. Please kindly take your seat on the dais. Thank you, sir. Your presence today adds the great value to this special occasion, and we are honored to have you with us. Ladies and gentlemen, please join in the welcoming with the warm rounds of applause for sir. So, to welcome the dignitaries on the dais, I'll request our director, Dr. Thamban Melot sir, to please give a welcoming bouquet to everyone. Dr. A.K. Muthunaigam sir, Dr. Harsh Gupta sir, Dr. P.S. Goel sir, Dr. Shailesh Nayak sir, Dr. M. Rajivan sir. Sorry. M is common. Yes, sir. And I'll take honor. Okay. To begin, we have an honor to invite Dr. Rahul Mohan, Group Director, Polar Science Division, NCPOR, to deliver the welcome address.
Namaskar and a very good morning to all the esteemed guests and friends, colleagues of NCPOR. Deo Boro Dis Deo. A very warm welcome to all the former secretaries of the Ministry of Earth Sciences, Dr. Muthu. A warm welcome to him, Padma Shri Dr. Harsh Gupta, Padma Shri Dr. P.S. Goyal, Padma Shri Dr. Sailesh Nayak ji, former NCPOR directors, founder director Dr. P.C. Pandey, Dr. Rasik Ravindra, Dr. S. Rajan, and of course, my current director, Dr. Thamban Melod. Directors from the MOES institutions, senior officials from the ministry, invitees, former NCPOR employees, Dr. Sudhakar, Dr. Arvind Mitra, Dr. Khare, Dalvi Saab, Shripati, Venkateshwarlu, Pradeep Sharma, Naguji, Sheila is not here today, yesterday she was there, and numerous others who are part of the NCPOR growth story. My seniors, my own NCPOR colleagues who are occupying, the younger generation is occupying the back benches, and the fraternity from the other spheres of life who have taken out time to be with us on this momentous occasion, including the press. I would be failing in my duty if, in my welcome remarks, I do not introduce you to two eminent scientists who have their names inscribed in the granite plaque at the entrance of NCPOR with the date 5th April 2000. Dr. Ibrahim E. Muthu, popularly known as the Rocket Propulsion Man of India, was Secretary to the Government of India, Department of Ocean Development from 1995 to 2001, and saw the inception of National Center for Antarctic and Ocean Research in the year 2000, and Dr. P.C. Pandey, two names I can see there, apart from the governor, who worked at different places, including SAC, and also at the NASA Jet Propulsion Lab in US. Coincidentally, both have a common word, and that's propulsion. And therefore, you can now understand how we got the big push. In Hindi, we call it pranodan. And I would, in the same breath, remember another great who was associated with NCPOR and Antarctic Study Center, that was late Professor U.R. Rao, and the committee members of that committee who made the initial document for NCPOR. And later, of course, Professor Rao was also our RAC chairman. But the document is still very valid today. If you go through the document, and I've been going through for last decade or more, and I feel it still it is relevant. And so nicely it was written. Big thank you to Professor Rao wherever he is and his soul. So आप सभी का आज NCPOR में तहे दिल से मैं स्वागत करता हूँ. Just to reiterate and tell you that Department of Ocean Development acquired about 15 square kilometers of 15 hectares of full-fledged land that we got here, and a research center for Antarctic research largely was instituted. But where you are sitting now, below, if you look at the seams, they are all garbage. And the beauty of it is, this is a real story, transformative story of wealth from waste. So when people appreciate our institute and center's location, when they come here, they are in awe, because they see that the ocean and overlooking ocean, and they feel that you are at such a beautiful place. And I always joke that had Pandey ji, the founder director, not taken pains, there would have been another 5-star hotel at this location. And this is a fact. As probably each one of you, if you have not gone around, those who are for the first time, please go around and see the breathtaking view of NCPOR. And if you sit peacefully, you can feel the waves and also get the salt spray on your face. You are sure to sight dolphins very close to NCPOR, and NCPOR has the best sunset point. If you love photography and if you love writing poetry, nothing better than this place. But we end up doing some good science as well. So a big thanks to all those who thought of having a center at this place, including CSIR and Bacha Singh and Varghese and others, the team who took the initial phase of construction, around which you see a new phase of buildings that have come up. And with the help of CPWD and our estate head, Ravikant Sharma, we are being able to develop it further because the requirements are huge of the new projects. So welcome on behalf of NCPOR staff. Thank you all for being part of the history, which the current youngsters will remember it in the next 25 years. और मैं आज इसको अंत करना चाहूँगा, अपने इसको विराम देना चाहूँगा और अविनाश से एक क्लू लेते हुए, क्योंकि वो हर बार एक शायरी सुनाता है, तो मैं भी कोशिश करता हूँ, मैं शायद उतनी अच्छी नहीं कर पाऊँगा। शुक्रिया तेरे आने से रौनक तो बढ़ी, शुक्रिया तेरे आने से रौनक तो बढ़ी, वरना ये महफिल ये जज्बात अधूरे रहते। आपका हार्दिक अभिनंदन है। धन्यवाद।
Thank you, sir, for the warm welcoming all the special dignitaries and their contributions and taking the history of how the NCPOR, the members has contributed for evolution of this NCOR to NCPOR. So next, I would like to invite our esteemed director, Dr. Thamban Melod, who will be taking us through the key accomplishment of NCPOR over the 25 years. So I'll request Thamban sir to please.
Good morning. A very warm welcome to NCPOR again. Respected distinguished guests on dais, former Secretary of Department of Ocean Development, Dr. Abraham Muthanayagam, Dr. Harsh Gupta, former Secretary of Ministry of Ocean Development and then Ministry of Earth Sciences, Dr. P.S. Goyal, sir. Dr. Shailesh Nayak, Dr. former Secretary, Ministry of Earth Sciences. Dr. Rajivan, Secretary, MOE, former Secretary, MOEs. And very distinguished dignitaries in the audience, invited guests, many of my seniors, my former directors of this institute, and many youngsters in this particular hall. Founder members, of course, I just want to very specifically thank them for coming all the way. First of all, let me admit that actually I have not prepared anything to give this about key accomplishments, although they just put it in the agenda. And it so happened that actually when a very nice, good event comes, we always get busy with hundreds of other things. We really don't, prepare ourselves. So that is my situation today. So apologies if I am unable to actually explain, the way it should be, as well as also, not able to bring those names which actually are being key figures throughout. And there are many figures which are on the background which we not normally hear. So I will not be able to all say that, but that's why I'm in the very beginning itself I am requesting that please forgive me for that. But I just wanted to give at least a kind of a small glimpse of things actually, at least what we could achieve in the last such a long period. This is one of those pictures actually with some of you people, the founders, remember so well. Just a small few blocks of building with nothing, no grass around. Even when in 2002 when I joined this institute, this place did have no grass. It was so dry. Because I came from NIO, I used to say that it's such a dry place. And dry means in every sense, there was no life, there is no grass, there is no trees, because trees are hardly growing at that time. So that is how it was. So therefore, it's an immense, pride and honor to stand before each one of you to, say that, I have this opportunity to be at this stage actually, that when things look so greener and better. So I don't take credit for that. It's all, on those giant shoulders which we stand, and then we are still able to, enjoy that, and at least we are able to move forward. So it's not only this Silver Jubilee is not just a commemoration of that, thing which, this 25 years, what all we just did, but it's also a reflection of those relentless hard work put by those founders, those people, from the ministry who envisioned that, okay, we should have an institution which will stand test of the time and will finally take this country forward. And also to the commitment of all those people who are involved in the scientific exploration, in pursuit of knowledge, of course, which is also, and finally it is leading to a, testament to the leadership which NCPOR is able to provide now. So, for a quarter of centuries ago, the visionaries which, thought, that most of them sitting in this, many of them sitting in this August gathering, who laid this foundation of NCPOR, we dreamt of an institution that would push boundaries of this, our exploration to the, the unknown mysteries in the remote places of Antarctic and maybe even beyond that. Today, as we look forward to, look back, to the, our journey, we see not just milestones or few buildings. We find a legacy created by people who had a vision, who was ready to suffer, take that extra miles, take that sufferings, and make this institution work. And also, it's a kind of a scientific ingenuity and a resolute commitment to what they believed in. So then, as what we started as a National Center for Antarctic and Ocean Research, NCPOR that time, in 2000, now it's blossomed into a fully functioning and respected, globally reputed, polar institution with activities across Antarctic, Arctic, Southern Ocean, Himalayas, and, the deep seas and so on. So as you're aware, this was some of those, those people must be having nostalgic feeling about this kind of pictures actually, for this, the founders, the earliest, pictures of the place. You can see all the way to the ocean that side, that there was no buildings that time, those days there. So you can see that. Then it became this one, and now that's where actually we really started going, more than what we just, thought at that time. Because, the kind of the limitations with that actually which we could start in Antarctica. So now that actually we started more than 2 decades of polar research, we have been able to explore Antarctica beyond that one particular place where we are doing it. Exploring into Arctic in Svalbard and going to Canadian Arctic and Central Arctic and so on. So for all that, I think we should thank the first and foremost, when this first expeditions to Antarctica started from the shores of this, Goa in 1981, by decisive decision by the government of India, under the leadership of Dr. Z. Qasim. So we should be all grateful to those, those people who are played in the background, people there in the government, and then people finally led those expeditions to make this happen, which ultimately positioned India as a key player in the global polar science. So with that, actually, we also solidified our commitment by building a fantastic research station called Dakshin Gangotri in 1983, followed by Maitri in 1989, and then a much more modern and energy efficient station somewhere in 2012. And all that actually enabled, we are able to do the research beyond just what we just, going to Antarctica. So the establishment of NCPOR therefore in 2000 itself made a huge difference to the way we handled polar programs and the way we, actually undertook those activities with a clear vision. So wherein we are able to go beyond what we just used to do, do only the research around the stations. We are able to set up small satellite hubs with far away from those stations, able to undertake international projects. Some of those colleagues actually we collaborated are here actually, who will be the testament to actually that how successfully as well as professionally the Indian researchers were able to actually undertake those operations and science, and then jointly put hand together not only in the field but also come back and do science of it. So all that is basically enabled because of actually we were able to set up state-of-the-art facilities at this center. Then we were able to take the science to this next level, and finally we were able to compete strongly with international community. So all these are basically ultimately actually that the proof of actually what we were able to move forward. Therefore, we are able to do science more than what we were able to do in the much earlier, and enabled we create an ecosystem of polar enthusiasts as well as young researchers in this country who blossomed into become polar scientists. And more than, as you can see, that nearly 3,000 people we were able to, we enabled them to visit Antarctic and carry out research. So this, all this NCPOR's basically study expertise and scientific and operational, expertise in those programs have been basically instrumental in advancing our understanding of the climate change, ice sheet dynamics, atmospheric sciences, and placing India firmly on the global map of polar research. So over the years, our footprints in Antarctica itself has expanded beyond those limits of the logistic limit of the stations. We've been able to make major international campaigns like this, the Indo-Norwegian MADICE project, Indo-UK-Norwegian SIVA project, the Indo-Belgium Japan project called Staples, and recently, taken up projects actually, projects like RICA, which is joining with, the many multiple international collaborations in West Antarctica, able to undertake projects like in seismic surveys on the in the glaciers, especially in the ice shelves, along with the Norwegian colleagues and so on. So that shows the kind of the confidence built now into our colleagues who are able to take science to the level which is actually respected in the international level. Operations which are sought after, like our operation teams are able to support so many huge international projects now, providing them the support, whether it's Belgium, whether it's Japan, whether it's Norway. So we are able to even provide operational support to those countries now for their various scientific projects. So that is the level which we are graduated from, actually, where we were depending on a lot of support from others. So I am grateful that actually that our people lived up to those expectations of our founders and those visionaries. So, so if it also, it's not only just Antarctica that was mattered to us actually, because it was important that actually as we look forward, it is important to be there in Arctic, because that is one of the most happening place on Earth, being the place which is warming 4 times larger than the global average, losing most of the sea ice in coming few decades, becoming a hotbed of geopolitics and strategic moves. So I think we made that particular decision going into Arctic in 2007, when the people like Dr. P.S. Goyal and Dr. Sikravindra and Dr. Shailesh Naik and so on, Dr. Rajan, for example, I should not forget that name, when we started this Arctic program. I think that move at that time might have thought it's maybe a simple move. I think that made a huge difference to where we stand now. So I think we should be so grateful to all of you that who made that difference. So where we are able to make not only just actually as putting our foot there, rather than actually able to take up research, because most of our Arctic research are either collaborative or research which actually are testament that actually we are not duplicating those others' work, because it goes through a strong international scrutiny. Unlike in Antarctica, we go through an international mechanism there. All those projects which we carry out should have value addition. So, for example, if you look at to investigate this, teleconnections between this, Arctic climate and Indian monsoons, many of our colleagues are working both on modeling and data-based studies. Setting up mood observatories, both in fjords. Now we are planning to, this particular summer, we are planning to expand into the deep ocean. And we are also able to undertake actually Central Arctic expedition. And for this year, for actually exclusively Indian scientists will be taking up an oceanographic cruise along the East Greenland Sea between the Iceland and Greenland. So that is the level actually I think we are again able to grow than what we were able to stuck to one point in actually in Svalbard. So I think that small step made a huge difference. So I want to really acknowledge that. So I want to say that actually again a key accomplishment, it is a kind of accomplishment for the overall the country itself. So even for example, actually like when we started actually with such growing expertise, now we are able to actually have a year-round expeditions in the Arctic. And even during in the winter time, actually, we have people, not only people, actually, people are collaborating with us, actually, because since we have that facility as well as we have the particular program going on, there are people from US and all joining our collaborative project, actually, even winter time. So that shows actually that, again, the growth. So our scientific endeavors not only stopped there, actually. I think in around 2012-13, that's the time, actually, I think, when Dr. Shailesh Naik was the secretary, that's also time which, Dr. Rajan was director, and then Dr. Rasik Ravindra was still with us, actually, as a kind of a consultant in the ministry. So it was decided, actually, we should have be able to go to Himalayan and undertake research on the cryosphere. Actually, I was very, I was not so much of positive at that time, I should say, actually, that because we were so overwhelmed with our own work, we were already spreading very thin. And as a scientist, I felt actually that, unless we go depth, actually, we may have a, problem like that. But I think such an encouragement push from actually people like, especially Dr. Shailesh Naik, I want to say that actually, he said, it's okay, you just start, you don't worry actually that things will fall in place. And actually things have fallen in place. I can very proudly say that actually things are really fallen in place, actually, the kind of scientific outcome, the kind of mark which we are in the national level actually for all glacier program which they call us, and including the NDMA for even for the hazard management actually that our own expert are now, NCPOR expert is sitting there actually because they understand our technical expertise which could help them into finally to bring them into early warning systems and so on. So that shows again a vision, I would say. Visionaries always think much ahead of time. So I think I want to appreciate that actually, to Dr. Shailesh Naik and Dr. Rajan and all of you thought at that time. And followed by actually, I think it was Dr. Ravichandran's time actually that, he gave such a free hand. I would say that actually you just take up, work anywhere as long as there is scientific logic and reasoning and you are able to do it. I think he was able to, that's why when we just expanded as fast as possible, I would say. So now we have become actually within the Himalaya itself, actually not only just in the western Himalaya, now the eastern Himalaya, we have started taken up glaciers in Arunachal Pradesh. Till now, nobody in the country has taken up actually because it's been extremely, so any glaciologist knowing actually that Arunachal Pradesh has been one of the most difficult place to access actually. Not only just due to the conditions along the border, but also because of the, the glaciers itself are in a very high altitude and the approach is so bad. So all that shows actually the kind of strength which we gained. So what I think in between I forgot to change the slides because actually when I just got excited, I would say that actually. So the polar regions ensured actually the kind of work which we carry out actually that what happens in the poles does not remain there. It impacts all of us. The kind of floods sometimes we see that we have connection there. So now our duty is ultimately to add that one value because the ultimately Indian monsoon being the finance minister and the prime minister, we should be able to at least able to contribute to one component to those forecast prediction in future actually that how much this can actually quantify in those, the predictions. That is something I think what we should be able to make in future. Because the kind of warming impacting us in all around is so much that in not only it's in ocean, but it's on land, on the cryosphere, on the, the overall health of the things, everything. So I just stand here. I think this is something very, very important project, which I also, if I say that actually, I would say one of the most important accomplishment for the last few years, I would say that. When we started, actually, again, there was, when the hydrothermal exploration was started in way back a few, almost a decade back in National Institute of Oceanography. With so many expertise, very well known, this one actually, and which, they were trying to do in the Carlsberg Ridge. And they had to stop at one place where they could never actually identify a hydrothermal vent, and also identify the real place where what thing happens. I think that's when actually, I think when this project came to NCPOR, then a lot of people must be making at that time actually, really, whether these guys are really seriously doing it about it. I think, so the kind of contract which we received from the International Seabed Authority, and the intense work which we carried out of that, even going today, actually, that there is a team actually sitting there in Mauritius, actually starting another expedition to going there. So that showed the commitment which finally brought us this. We were able to identify the actual black smokers, this actual photograph which is taken by our team, the actual hydrothermal plumes, the chimneys, the life over there, and the mineralized zones there. So if you look at the entire areas which we identified, we studied, we have not only discovered hydrothermal vents, there are several active hydrothermal vents we identified. We also identified potential sulfide deposits. So that is somewhere actually where we stand now. I think this is something which will make a huge difference in coming years, the ability for us to do further study them and ultimately contribute to the country in a way which, useful. So that makes, we have also been very lucky to be part of many of this policy making, whether it's India's Arctic policy or India's Indian Antarctic Act. All this ensured that actually we have been able to contribute to a level at the international level, and international level playing grounds. So our future is also actually, as we expand, we need to expand our platforms. We need to have a new polar research vessel. It's been in the process, and I'm very hopeful the government, would be able to support us actually, because as yesterday Dr. Rajivan was telling, if they really put up a good proposal, it's so convincing. I don't think government will never say that. I think it was a conviction from our side, and our ability to justify, that is what most important thing. I think that strong push is what we should do it. So finally, as we stand, this was yesterday's picture actually, that it was all, we could not get a best photograph. We just got one photograph. So all will not be looking great in that. I apologize for that. But I would say that, basically all the scientific research or activity we carried out was never in isolation. Over the years, actually, we fostered global collaborations, national networks, and invested on people and people-to-people interactions, and so on. So that makes what we, final commitment to all the sustainable, leadership, evident in many of those, the policy areas which we still sought by many of those government agencies. So ultimately, as we stand at this historic juncture, I would say that it is very imperative to look forward, because the challenges of the polar research are immense. But I only want to say that there has been never a better time in polar research, because, of course, there are so much of issues going around the current geopolitics problems and inability to access certain areas and so on. But the climate change has brought the polar regions to the center stage. Whether you look at the decade of the cryosphere which is going to happen, or the decade of oceans and so on, everything, essentially almost all policymakers are convinced that the climate challenge is so much that actually at least you should invest more and more into it. So it is up to us, ultimately, I would say that, to live up to those expectations and to bring our science and our activities to much higher level than what we are now. So it should be our scientific endeavors also must be complemented by our investment in capacity buildings and nurture youngsters. So as we are so happy that I always feel so proud to say that actually that when we were struggling as when we joined here to get 1 or 2 PhD students to come here, we have 40 PhD students, all of them net qualified, and that kind of students we are now. So that's steadily increasing, and because that just shows that actually the confidence these youngsters feel in this institution and our science, what we do it, and the exposure they can get it. I think it is a responsibility of each one of us to ensure that those who come trusting us should be given that opportunity to grow. So, so as we celebrate this Silver Jubilee, we are not just marking a milestone, but reaffirming our commitment to scientific discovery and environmental responsibility. Of course, our past is rich with achievements, but our future is much more important and for the, and promise. So the work we do today will shape the future of the next generations, and it's important for us to work together, where science should lead the way in addressing greatest challenges of what is happening in the time. So thank you so much. So together let us ensure that NCPOR continues to be the beacon of excellence in polar and ocean research, inspiring generations to come. Thank you so much. Thank you all for your time.
Thank you so much, sir, for taking us the remarkable journey and the new height which we have received and achieved by NCOR to NCPOR under the polar and ocean research. We have not only we started the organization with just for the operation purpose, and then we are growing with the science and touching the new height of the science. आज का यह शुभ अवसर हम सभी के लिए अत्यंत गौरवपूर्ण है। 25 वर्षों की इस अविस्मरणीय यात्रा में हमने न केवल ध्रुवीय और महासागरीय अनुसंधान में उत्कृष्टता प्राप्त की है, बल्कि विज्ञान के क्षेत्र में नए आयाम भी गढ़े हैं। इस अवसर पर हमारे समर्पण, अथक परिश्रम और नवाचार की भावना का भी उत्सव है। यह सिल्वर जुबली केवल एक उपलब्धि नहीं है, बल्कि हमारे संस्थान की अथाह संभावनाओं और उज्जवल भविष्य के लिए बढ़ते कदम का प्रतीक है। हम सब आज एकजुट होकर न केवल अतीत की उपलब्धियों को संजो रहे हैं, बल्कि एक नए संकल्प के साथ भविष्य की ओर अग्रसर अगले चरण की ओर बढ़ते कदम बढ़ा रहे हैं और विज्ञान के इस प्रकाश को और अधिक प्रखर बनाएंगे। So it is an honor to welcome our keynote speaker, Dr. M. Rajivan sir, Vice Chancellor of Ataria University and the former Secretary to Government of India, Ministry of Earth Sciences, a visionary scientist. He has transformed India's monsoon research significantly, enhancing forecasting accuracy and strengthening the agriculture, disaster preparedness, climate resilience. With an MSc and PhD in physics, he has helped leadership role in India's premier meteorological institutions, including Director of National Center, Climate Center, Director of IITM, and Secretary MOES. Sir is the architect of Indian Monsoon Mission 2012, an innovative initiative that has advanced the climate modeling and monsoon variability research. His extensive contribution include IPCC report, over 150 research papers, pioneering studies on climate change and extreme weather event. He has served a key global role as a chairman of RIMES, consultant of WMO, and expert member of WMO Climate Service Information System. Additionally, he has contributed as associate editor of the leading scientific journals and chaired ISRO expert team on meteorological satellite system. He has been awarded with several awards. I will include some few: the Fellow of IAC, INSA, NSI, Atmospheric and Climatic Sciences. As we explored its vast and critical link between the polar regions and Indian monsoon, it is privilege us to invite Dr. M. Rajivan sir to deliver his keynote lecture on polar monsoon linkages. Sir, we welcome you for this wonderful lecture. So before we start, we'll give you a big round of applause for him.
Yeah, good morning all of you. I'm seriously thinking of changing my name to Ravichandran. So thank you, Dr. Tamban, for inviting me to this 25 years celebration of NCPOR. I'm very delighted to participate, and I am very sure the last 25 years NCPOR has done wonderful things in polar research. As Secretary MOES about 5.5 years, whatever I could contribute to the Institute growth I have done. I should take the sole credit of changing the name of NCPOR to NCPOR. I remember discussing with Ravichandran, he was saying that we are doing work on Arctic, we are doing work on Himalaya, then the name of National Center for Ocean and Antarctic Research is not really a good name. So we thought, I remember issuing the Gazette notification for NCPOR. And they have done wonderful work on not only Antarctic, of course, they are the founders in the Antarctic policies, Antarctic Act, and they have been doing it last many years. But Arctic and Himalayas, they are the new entrants. But last 10-15 years, I am very sure that, I know that Arctic, especially in Arctic, they have done wonderful work. And Himalayas, I remember going with Ravichandran and Tamban in the helicopter, going to Himansh, and seeing the observatory in there in Himalaya, 4,500 meters above sea level. I was a little scared because the helicopter had only one engine. But I wanted the Honorable Minister to come, but then his PA was saying that Minister will flow only, the helicopter has 2 engines. So we did not have the provision of doing it, so I came with Ravichandran and Tamban. So I'm very happy that Institute is really getting good name. It's an internationally acclaimed research institute and doing a lot of research work, and I wish all of you all the best. And the basic strength of this institute is the young people. There are a lot of young people joined here who are young researchers, and I'm seeing the research papers coming out from this institute, wonderful research papers. Some of the research I will be showing here in the institute. I was asked to give a talk on polar and monsoon, but then I remember 2023 I came here in the National Conference on Polar Science, NCPS. I gave a talk, keynote address, about 45 minutes. I saw the slides, some number of slides were 70, so for 25 minutes or 30 minutes I am not able to do it. So I thought I'll talk only on Arctic connection with the Indian monsoon. Okay, thank you. Yeah, this is the title, Arctic Sea Ice Variability and Indian Summer Monsoon. So this is the monsoon rainfall. All of us know it's the bread and butter. This is the left-hand side is the mean rainfall, right-hand side is the year-to-year variability of Indian monsoon. There are years in which we have droughts. There are all the red bars are droughts. Blue lines and green lines are excess monsoons, and there's a black line over there. There's a multi-decadal variability. So in addition to year-to variability, there's a 30 to 60 year cycle of monsoon variability, in which some epochs we tend to have more droughts, some epochs we tend to have more floods. And now we are entering into a positive epoch in which we can expect less droughts and more of floods. And why Arctic and Antarctica is important, because they are both are the cooling chambers of our planet. And last line is very important. Polar regions also have large control of the global energy balance because of large sea ice albedo, and snow ice have large albedo. And also it controls the temperature, it controls the energy systems, etc. So these both Arctic and Antarctic are very, very important, not only for Indian monsoon, for the whole global climate system. So in this way, the polar regions basically regulate the distribution of the heat on of the earth. Then Arctic amplification is well known. All of us know that global warming is happening, temperature is going up, and also very rapidly. So that's why yesterday we are discussing last 100 years. We see that already it has crossed 1.2 degree or so. The warming is happening at appreciable rate, not on the geological time what we had seen in the geological time, but the kind of temperature increase. But last 100 years, the temperature increase is much more substantial. And very interesting thing is the temperature warming is not really distributed uniformly around the globe. Arctic is warming much more than the whole global average. It might 4 times more trend, a larger trend than compared to the global average. Why it is? There are a lot of reasons. One is reduced summer albedo. More solar more warming, it will reduce the sea ice, so albedo will be reduced. So then we will have more absorption of solar radiation. Then total water content, because more temperatures means atmosphere can contain more atmospheric water vapor. That is basically a greenhouse effect. So it is a kind of positive feedback, changes in the total cloudiness. So there are all reasons the temperature over Arctic is increasing substantially when compared to global average. So we call it Arctic amplification. And because of Arctic amplification, sea ice is reducing, sea ice is melting. Left-hand side shows the mean climatology from satellites. Right-hand shows the trend of last many years. And you can see that everywhere decreasing. Sea ice is decreasing. But it's not, again, it's not uniformly. Over the central Arctic region, the trend is much less when compared. So the trend is much more on the periphery of the Arctic Sea. That's more important. Right-hand side shows the kind of a month-wise and year-wise what is kind of a sea ice variability in millions square meter, kilometer square. So what you can see, the all red are all reducing. So you can see that most of the temperature decreasing trend or sea ice melting is happening from July to October. And September, all of us know that that's the lowest sea ice we can observe. And so from 2005 onwards, the trend is much more substantial. So the rapid decline of sea ice is happening in the Arctic region. That's very interesting to see. So, okay, so sea ice is decreasing, so it can affect the local climate. There's no doubt about it. But the question is how it can affect the monsoon climate. So there are four pathways. There can be many more, but I thought these are 4 very important pathways. One is through mid-latitude circulations, and just north of that mid-latitude Eurasian subcontinent, you can have changes, and it can affect. And also it can change the Tibetan, for example, there's a paper came out that it can affect the aerosol loading over Tibet. And it can, of course, affect the temperature over Tibet. And the very interesting thing is Atlantic meridional overturning circulation, AMOC, is weakening, is slowing down. So that could be one pathway. Hadley cell and intertropical convergence, so so-called ITC set is getting shifted, and Hadley cell is getting shifted because of the changes in the sea ice. And last one is the ENSO. So it can affect even the frequency of ENSO events, which I will show some examples. So before we talk about the teleconnections or the impacts, what we need to understand is the difference between winter and summer climate over Arctic. Winter, we have more of a what happened? Okay, so winter you have more of a stronger jets and polar vortex because temperature gradient is very large, so you have a strong polar vortex. Whereas in the summer we have a weak subtropical jet and double jets you can expect. And below, what is very important is the shorter stationary waves. Instead of a longer stationary waves, in summer we get a shorter stationary waves which can really contribute to monsoon. It can affect the monsoon circulation. I'll give the examples. This is a very important slide which shows that when warming is happening, what is happening is the weakening of storm tracks in the Europe. And equatorial shift of polar jet comes down towards southern latitudes, whereas subtropical jet moves north. So these are the 2 important things which we need to notice. And last important thing is amplification of quasi-stationary wave, short wave trains. So in the middle latitudes, you can experience every winter, you can experience of a moving, short waves are moving, we call Rossby waves, etc. So these waves now, instead of a longer wave, it comes as a shorter wave, and frequency also is increasing, which I'll show in a slide. And if you really see the last many years of what is the monsoon teleconnection with upper tropospheric circulation has strengthened a lot. And if you can see the right-hand side, you can see the red, blue, red, blue. This is basically nothing but Rossby waves. And that effect is seen much more in the recent years. The effect of middle latitude circulation on monsoon. Rossby, the relationship between Rossby wave and monsoon circulation is well known. It can affect, it can lead to a break condition. It can sometimes, if it is the phase is right phase, we can increase the extreme rains. For example, 2013 Uttarakhand floods was basically due to a Rossby wave moving. And it can interact with the monsoon circulation, it can cause extreme rains. And in some occasions, the phase is not really good. It can pull up the monsoon trough towards Himalayas, and it can lead to a monsoon break. So so the relationship between Rossby waves and monsoon is well known. So the frequency and the strength of Rossby wave patterns, the circulation patterns, is now getting strengthened now during the recent years. This is very interesting. This is a paper that just came out a few months back by Hunt. He is working in university reading, and which shows that, I don't know, you must be seeing in newspaper, the winter precipitation over northwest Himalaya is decreasing. They are not getting enough winter precipitation now. It has a large implication in terms of rabi crops, etc. But what is very more important is that the whole western disturbance is getting shifted to the pre-monsoon season. Instead of winter months, it's all getting, now we tend to get more and more western disturbance in April, May, June, even up to extended May, June. The western disturbance, you know, it's a kind of a middle latitude weather systems coming down and giving rain in winter precipitation over Himalayas and northwest India. And when monsoon comes north, these all things getting shifted to northern latitudes, then we don't see any western disturbances. But now we say there's a delay in the western disturbance going north. There's a shift in the monsoon pushing the western disturbance to north. So we tend to get more and more western disturbance in the month of April, May, June. You may be remembering the 2 years back, we had a very severe flood in northwest Himalayas, like Himachal Pradesh, including Punjab and Delhi, last 2 years back. Heavy precipitation last month of June. So all mainly because of the western disturbance. So the western disturbance frequency is in the month of June, and to some extent even part of July, it is getting strengthened. So that is one of the real worry we have. And it's all caused by the changes in the subtropical jets, and also middle latitude circulation. It has a role, influence from the Arctic climate variability. And so this is the way middle latitude circulation plays a role in monsoon variability. Now I'll move on to how these Arctic sea ice can change the frequency of El Nino. And El Nino, we know, severe El Ninos can really cause more droughts over the country. So El Nino and monsoon relationship is well known. So what this paper shows is basically a model study along with the observations. What they say that, of course, they used the 3 SST gradient for defining El Nino event, and all these three indices of ENSO, they find that when sea ice, Arctic sea ice is melting, as more of sea ice is lesser and lesser, what will happen means the frequency of extreme El Nino events is increasing. It can cause more and more extreme ENSO events, not just the the moderate El Nino events, but it can cause more and more extreme El Nino events, which we know that a severe El Nino can really pull up the monsoon down, so we can expect more and more droughts. And also he found an explanation for how it happens. Basically, it's all triggered by the large-scale patterns in the northern hemisphere. The so-called Siberian high is getting strengthened, whereas Icelandic low is Aleutian low is reduced, again strengthened. So that can cause circulation features which is shown in the below. And you can see there's a large-scale convergence over there, and also it's a large-scale convergence over the equatorial Pacific, and also it's a lot of warming is happening. So it indicates the presence of more and more El Nino events. So reduces sea ice, Arctic sea ice can induce more and more problems. So there is a high probability of more and more ENSO events. Now, so that has been shown by this experiment by, it came in 2-3 years back. It's a Nature Geoscience. It's a very famous paper. They did the 2 experiments, one with Arctic and both Antarctic, and see that how's the global effect. So they reduced in the model, they reduced both Arctic as well as Antarctic sea ice. And the top one is the Arctic sea ice rise. You can see that there's a lot of precipitation over equatorial Pacific Ocean, which indicates there's more and more El Nino events. And whereas Indian region, you can see it's all brown or red color, so which shows the monsoon rainfall is reduced. So if you put the both A and AA, both Arctic and Antarctic, you can see the appreciable difference, appreciable change in the monsoon rainfall, decrease in the monsoon rainfall over the Indian region. Okay, so I'll move on. The next is the so-called Atlantic Meridional overturning circulation, because all of you know that it transports heat, accounts for 25% of maximum global ocean meridional heat transport. It's a very important oceanic physical processes is happening in the whole world. It regulates the whole global climate. If anything happens in the AMOC, it can have a devastating effect, not only over India, but the whole globe. And so this is large-scale circulation, which you see that, and it's, of course, I need not describe how it happens and all. And what is really happening, the so-called AMOC is slowing down. So we can have an index on AMOC, index nothing but is the temperature over North Atlantic, subpolar North Atlantic, and difference of subpolar Atlantic, and from the northern hemisphere you can do that. And that AMOC index, you can show that, you can see that color, red color, it is all decreasing. And the bottom figure is very interesting. Every year is, if you really see that the global warming SST trends, you will see a pocket over North Atlantic, subpolar North Atlantic, where it's cooling. So all globe. Every year is warm. If it reaches the whole globe, only over there it is cooling. And that is nothing but the slowing down of AMOC. So slowing down AMOC is very much best established. So, and now question is, what are the implications of slowing down of AMOC in Indian monsoon? So there's hundreds of papers are coming out, not only for Indian monsoon, but the whole Asian monsoon system. And one of these papers, so this is the experiment which the people have done is, in the model what they have done is they reduce the the Arctic sea ice, and it can see that AMOC is now weakening. It's for almost 200 years. It's model simulation, and there are shifts in ITC set, and also there is a shift in Antarctic sea ice changes. So what is really happening in the initial years, AMOC changes are very appreciable. But ITC said what is really happening is it's going north in the first few years, but afterwards it's going south. Okay, after many years, after a couple of years, some more years. On multi-decadal time scale, Arctic sea ice declines leading to the weakening of AMOC. It's very clearly seen it's all coming down, and also mediating the direct, and also longer time scale leads to weakening of AMOC, and also mediating the large impacts of Arctic. So ITC that also is coming down. ITC is coming down, the whole system is coming down, it can really impact the Indian monsoon. This also came a few months back on how the AMOC collapse can affect Indian monsoon. So the whole monsoon system, so they identified 4 regions of monsoon: East Asia, Indian monsoon, African monsoon, and also the so-called South American monsoon. And they found that model, 4 different models they put in, and they introduced the slowing down of AMOC in the model. CS is the CS, they made it, they reduced it, then it caused the AMOC changes, and AMOC changes are produced in this kind of thing. You can see that everywhere is all red, orange and red in our Indian monsoon region, and they assume that about 18.76% of more deficient rainfall can happen only because of the changes in the AMOC. This is the study by Chatterjee. It's all, I think it's all NCPOR work. What here is showing us, this is the left-hand side, the bottom, the top one clearly shows how the JJ sea ice content extent is changing, and it was increasing. Then the last many years, so it is decreasing. Last many years, you can see it's the scale is in the reverse order. 4 is the top, and you can see the sea ice is decreasing. Along with monsoon rainfall, it is going up, but it is decreasing nowadays. So the phase, earlier we had the phase between sea ice and Indian monsoon rainfall, but now there is no phase. The phase is going out. It's just out of phase. So sea ice is decreasing, but monsoon rainfall is still less. But what is very important is the frequency of extreme rainfall is also going along with the sea ice changes. If less sea ice changes, it causes more and more frequent extreme rainfall, especially in the month of September. So this is a very important study which we, last time also I remember I showed it in the presentation. So how it happens is it happens in the circulation features over the monsoon region. So for example, if you go back, you can identify the events or the decades, the periods in which you have more sea ice and less sea ice, and you can divide the whole period. And if you really see the differences between these two periods, you can see that left-hand side, the blue color is nothing but vertical velocity. It's all positive. That means it's a good monsoon. And you can see that it's a lot of large-scale cyclonic circulation, a huge monsoon flow, large-scale monsoon flow. But it's the other side, you can see it's all descending in motion, and monsoon circulation is just opposite. It's all weakening monsoon circulation. So sea ice is again impacting, and it can also lead to extreme rainfall events especially in the month of September. This is very interesting. I used to show this map everywhere. As I told that in the beginning, that we have a large-scale multi-decadal variability, and if you really, and also we know that it's triggered, it's all largely influenced by Atlantic circulation, Atlantic Ocean. Atlantic Ocean has a multi-decadal variable called oscillations called AMO, and AMO monsoon variability, monsoon decadal variability goes well and together. But in recent years, you can see that it is going up, it's going down. Where monsoon rainfall is in the lower epoch, still AMO has gone up. So question is, last many years, there is a out of phase between AMO and monsoon rainfall, even in the multi-decadal time scale. The question is why? Some people say it's because of Indian Ocean warming. Some people say it could be related to Arctic sea ice. It's a gray area. Some of you can take up and work on this problem, whether Arctic sea ice melting is really influencing the multi-decadal variability of monsoon. We normally study the year-to-year variability, but it's very high time that we try to understand how the relationship between Arctic sea ice extent and as well as Indian monsoon. This is another studies we say that Arctic sea ice is also will reduce the synoptic scale activity. The number of lows and depressions forming over Indian region also will reduce. It's a very famous paper, Varnesh Chandra from IIT Delhi. So you can see that the model, right-hand side, you can see the frequency is reducing synoptic system, lows and depressions. And you can see the vertical bar, the histograms. You can say low end depressions are reducing when you induce the low sea ice, whereas depression, deep depression, severe intense cyclones are not really changing. So there is a clear signal saying that sea ice decrease can influence the synoptic scale activity over the Bay of Bengal and in monsoon region. And this is a very famous paper. This has come out just few months back, again by Jugi and Avinash Kumar group here. It's also very categorically. So they've done an experiment with the data as well as they did a method called singular value decomposition. It's a very powerful tool, statistical tool, and they applied that, and they found that there's a good relationship between sea ice changes and Indian monsoon rainfall. You can see the right-hand side, but the relationship is not uniformly distributed over the whole country. The northern parts is different, and southern part and west coast is different. So the question is why? If a large-scale pattern should really influence monsoon, why it should not affect the whole monsoon region alone? Why they should have two different kind of mechanisms? So that we need to really understand. I don't have an answer for that explanation. And if you really see the whole Arctic region is divided into BKSI, I should really see what is BKSI, Barents, Karas Sea, and central Arctic region, and see the and total. And you see the correlation patterns are different, very, very interesting. So the Arctic region, the sea ice changes is not uniformly related to Indian monsoon. A sea ice change in Barents Sea is different, the influence of Barents Sea is different from Central Asia Arctic region. So the relationships are different. If you really see the left-hand side, bottom one, you see that it's a positive relationship between Central Arctic Ocean. But whereas in the BAK region, it is negative. If you put it together, you still will get a negative but smaller number. So the relationship is not really uniformly distributed. That is very important to know. And of course, they give an explanation why it is happening, mainly because on the top, you see that you have large, very strong subtropical high, and also a lot of easterlies, and also large vertical wind shear that can cause good monsoon. And this is the physical mechanism which they say a Central Arctic sea ice highs can lead to stronger pressure gradient between high and middle latitude. It can strengthen the Asian jet along at the northern Atlantic exit region, induce enormously high pressure over Central Asia. It can ultimately lead to anomalous easterlies, and south of subtropical high is very strengthened, and atmospheric instability can go up, and ultimately it will lead to good monsoon. Similar way, the Barents, Karasi, low sea ice also can be explained. Another paper recently, again a recent paper by General Hydrology by Agarwal group at IIT Roorkee. So they had also done two experiments. One is on the Atlantic Ocean part of the Arctic region, another is the Pacific Ocean of the Arctic region. and they tried to understand the difference between these two. And they found, and they also did an experiment not only for the year-to-year variability, but also they went up to different periods up to 32 years or so. And this is the bar you can see. In the Pacific region, you can see that this relationship even extends up to even multi-decadal time scale. So not only year-to-year variability, it's even a multi-decadal time scale. The sea ice changes have influence on Indian monsoon. That's a very interesting study. And that's why in the beginning, I said that we should really focus more on multi-decadal time scale also of the relationship between these two. And of course, they have, again, they have classified between, so made the composites between excess and deficient monsoon years, and they found that deficient monsoon, and also you can see that the distribution of the anomalies are not very same. Only some specific region, the anomalies are very strong. Other regions, anomalies are not very strong. But there is a big difference between excess monsoon and deficient monsoon. And of course, they are also given explanation in terms of large scale pattern changes in the 200 millibar, that means 12.5 kilometer, in terms of large scale subtropical highs and low pressure systems, etc. This is the path they have described. Atlantic Arctic sector Pacific Arctic sector can influence through NAO, North Atlantic Oscillation. The atmospheric pathway can induce ENSO, and ENSO can cause AES. And now what we have so far, what I discussed is how Arctic sea ice changes can affect Indian monsoon done by different pathways, like the circulation, ENSO, changes in the ITC set, and AMOC. These are the 4 pathways. And now I will show 2 interesting results. The sea ice changes can be induced by Indian monsoon, the other way. A large scale heating, Indian monsoon is a large heating source for the whole global climate. So large, gigantic monsoon region, and it heats up, it produces so much convective clouding. So convective clouding, nothing but latent heat release, it's a huge heat source. And this heat source can propagate into Arctic region, it can induce changes in the atmospheric patterns there, and it can give rise to low sea ice. Very interesting results. This is none other than Krishnamurthy, T.N. Krishnamurthy, the famous meteorologist who is no more now. And he has produced this kind of charts which says that any heating over Indian monsoon can propagate to the Canadian region. From there, it can propagate to Arctic sea ice, and it can cause kind of low sea ice. It can melt the sea ice. And so that is one paper. But recently, one thing again, a few months back, it came in Beiji Science, Atmospheric and Climate Science paper. It's a very famous paper again. This is Indian summer monsoon's role in shaping variability of sea ice. This paper also very clear. This is a model study. It's a very strictly model study. And what they have done is very interesting. And so when you talk about when you talk about Arctic sea ice and Indian monsoon, ENSO is a big killer. We know ENSO is a very big player for influencing Indian monsoon. So any influence of ENSO should be removed when we talk about the relationship between Arctic sea ice and this. We don't do. So when we get the signal between Arctic sea ice and Indian monsoon, we assume that it's completely influence of Arctic sea ice, which may not be. So there may be an influence through ENSO also. So we have to really, if you really do the data analysis, it can be easily done by removing the ENSO signal, by doing a regression analysis, remove the ENSO signal. Then you do again a kind of a statistical analysis. So these people have done that analysis, but it very clearly says that Indian monsoon can induce changes in the sea ice by decreasing the sea ice there. And also they have given an explanation in terms of large-scale circulation pitches in the Arctic Ocean, and especially in the upper troposphere. This is the bar chart which they show the physical mechanism, how they can do diabatic heating of ISM monsoon precipitation, can do Arctic anomalous circulation of Arctic region, and there are 2 pathways only through the thermodynamics, is making clear skies, that means more solar radiation, it can melt the sea ice, and also dynamic, sea ice drifting because of large scale winds. It can drift the sea ice and can reduce the sea ice there. Now, I'll stop with the 2-3 slides, and what we need a priority research areas. I'm strictly speaking about Arctic sea ice. We need more and more observation. It's a huge, large area, so in situ observation may not be alone, may be required. So we need more and more satellite observation, and also of course in-situ observations are required. And we know the sea ice extent, but what is more interesting is sea ice thickness. Because the dynamics and as well as the energy budget all depends upon how thick the sea ice is, not the extent. Extent is important, but also thickness. So we need to have observations, sea ice thickness, extent, and also the movement happening, dynamics. And we also need to do paleoclimate studies. Tamban's group is doing a lot of paleoclimate studies in Antarctic. We need to do on Arctic also. And because if we know the past history, we know what will happen in the future. So that is more important. And focused modeling studies we need. We run the model, but while analyzing the results, we make hypotheses and test it in the model, but then many times the significance of the model results, we don't test it. We simply run the model and get the results because it's easy to publish paper. But if you really want to get through a breakthrough kind of understanding of the relationship, we need to really much more sophisticated statistical analysis by doing statistical significance of the results, whether it is influenced by, it could be a lot of nonlinear interaction among the climate systems. And last is, I request Tamban to start a project called Polar Reanalysis. So reanalysis data we have, but very less number of data sets have come. You should do exclusively a reanalysis data sets you should produce only on polar regions, Arctic and Antarctic. You must have a lot of proxy data, you must have a lot of satellite data, you must have a lot of in situ data spread over the whole globe. You can always collaborate with some countries. You should bring out. You must be knowing that the so-called NSUB reanalysis, the ERA reanalysis, how much information it is producing now. So, but the data from the polar regions are not much gone into the model, in the reanalysis. So we need to have exclusively a reanalysis. This is my personal view and personal recommendation for you. And basic problem is models. How best our models are. CAs in the, of course, coupled climate model are improving, there's no doubt. Still we have issues, especially on clouds, etc., cloud feedback, ocean feedback. But this is the one study which has come out recently, again showing that, again by the Rookie group, the last one, bottom one is the observed data of mean sea ice and how the different models are producing. You can see large scale variability. Some models are not even producing any sea ice there. Okay, so even in a mean sea ice condition, the model is not pretty good. The question is why, how? And the right-hand figure shows how the sea ice is changing. The black line is observation. And you can see how much spread in the model. Huge spread. Each model is producing different kind of results. So we need to improve coupled climate model if you really want to understand polar climate. That's my last statement. If you really want to understand polar climate, you need to improve the model. Because you cannot do all information from data alone. You need to test your hypothesis using model. At present, my gut feeling is models are not so good for understanding this polar climate variability. Polar climate, not only polar climate variability. I think Tamban's group here, I remember when I was secretary, I remember advising Ravichandran to start a modeling group here. I don't know how it happened. Also, you should collaborate with IITA modeling group. They have a system model. And I understand from Dr. Krishna was saying that their CAS representation is pretty bad. So you people should really help them to improve the CAS representation in the climate model. That's my last word. Thank you. I will give an advertisement, because you gave me some time. I have to give an advertisement. I published a book on Asian monsoon last month. I think if you are interested in Asian monsoon, please buy and read the book. It's very cheap, $125. Thank you very much.
Thank you so much for your very informative and very scientific. Sir, you have made that how the global warming is affecting Arctic and their teleconnection to especially for the Indian monsoon. This is really, it has the deepen our knowledge and understanding the monsoon and Arctic connections. On behalf of NCPOR, we are deeply appreciate your contributions to the science and for especially for all the young researchers who is going to make their career on polar research. Yes, I think tea is ready, so we can have a break and we'll join again then. 11:30 was there, sir. It is ready. Yeah, it will be ready. Yeah, I think.
Chairman, dignitaries on the dais and off the dais, and all participants present here, ladies and gentlemen, greetings to all of you. The National Center for Polar and Ocean Research is one of the R&D centers of the Ministry of Earth Science, former Department of Ocean Development, Government of India. A review of the genesis of DOD and its progress over the years will give a picture of NCPOR. As you know, DOD was created in July 1981 as part of the Cabinet Secretariat, directly under the charge of the Prime Minister. From March 1982, it became a separate department of the Government of India. The mandate was to formulate and implement programs in ocean science and technology with a long-term scientific, technological, and economic benefits. The programs of the department were formulated based on the 1981 Ocean Policy Statement and the allocation of the Business Rules 1961. On the international scene, the department took active steps to demonstrate the principles enshrined in United Nations Convention of the Law of the Sea, UNCLOS, and Antarctic Treaty System, ATS. India ratified UNCLOS in June 1995 and the Environment Protocol of the Antarctic Treaty System in April 1996. Implement of the UNCLOS, which came into force in 1994, provided extended area of national jurisdiction in the sea for the exploration of living and non-living resources in the exclusive economic zone and also continental shelf. Towards this, a major contribution came from this center, as you will hear shortly from Dr. Harsh Gupta. Dr. Qasim was former director of NIO, was the first secretary of the DOD. During the middle of the 8th five-year plan, on 17th of April 1995, I joined DOD. What a transition from the propulsion system for spacecraft and launch vehicles to in the space program to ocean, the last frontier on this planet. I observed serious limitations faced by the department in early days in the implementation of the priority programs due to lack of institutional infrastructure directly under the management of the department. Also, the coordinating role of the department in relation to other ministries and departments could not be pursued effectively in the absence of any apex body such as Ocean Commission. When I joined DOD, the major activity of the department was annual Antarctic expedition and associated research, for which about 70% of the budget was allocated. Another 15% was allocated to oceanographic research at National Institute of Oceanography of CSIR, Goa, and the remaining was spent in administration and international programs. I felt the need to strengthen the S&T focus and establish adequate infrastructure to back up and monitor, guide, and implement the projects in an effective manner. I observed the National Institute of Oceanography at Donapalo Goa, established in January 1966, was a premier institution in promoting ocean science in the country. It was one of the institutions under the CSIR. I felt that NIO should be with DOD for the promotion of all ocean sciences activities in the country in line with the national ocean policy. I took up the issue with the Committee of Secretaries under the chairmanship of the Cabinet Secretary, but I was not successful despite 2 attempts. The setback was solely due to the unwillingness of the Director General CSIR to part with NIO. NIO still is not part of DOD. However, I extended the activities of the department in technology development programs to the R&D laboratories in CSIR, ICAR, IITs, and other academic and research institutions. By introducing programs oriented towards the technology development during the last 2 years of the 8th five-year plan, several new initiatives came up, and the total financial outlay of the department during the 8th five-year plan was 224 crores, which was more than double the outlay of 108 in the 7th five-year plan. To identify the programs of the department for the 9th five-year plan, I constituted various expert groups with eminent scientists as chairman to develop a 10-year perspective for the department. They were Dr. U.R. Rao for polar science, Dr. E.G. Silas for marine living resources, Dr. S. Varadarajan for drugs and chemicals from sea, Dr. V.K. Gaur for minerals and energy, Dr. Arkat Ramachandran for marine environment and coastal zone, Dr. R. Narasimha for ocean atmosphere and climatology, and so on. Based on the input from the experts, I identified ongoing programs with continuing and increasing efforts and new initiatives for direct benefit to the targeted sections of the society. The working group for the 9th five-year plan projected a budgetary support of about 900 crores for the plan schemes, but the Planning Commission fixed an outlay of 510 crores. In spite of the fact that this approval was more than 200 times the expenditure of the previous five-year plan, a number of prioritized projects either has to be deferred or implemented in low key. In line with the approval of the Planning Commission, I took steps to recruit and restructure the department and programs with focus on deliverables for the socio-economic benefit of the community and the development of the nation. My first action was to reorganize the scientific wing of the Department of Ocean Development headquarters on the line of ISRO, adopting program-oriented approach. In order to encourage focused program implementation, I assigned the responsibilities with accountability to my senior colleagues in the headquarters and also established a management system. In addition, I established 3 autonomous institutes: National Institute of Ocean Technology, NIOT at Chennai, National Center for Antarctic and Ocean Research, NCPOR in Goa, and Indian National Center for Ocean Information Service, INCAIS, in Hyderabad. In addition, I instituted 2 attached offices of the department: Integrated Coastal and Marine Area Management Project Directorate in Chennai, Sagar Sampada Vessel Management and Marine Living Research Coordination Cell in Cochin, which subsequently was renamed as Center for Marine Living Resources and Ecology. As we know, India entered the Antarctic realm by launching the country's maiden expedition to the ice-covered continent from the shores of Goa in December 1981. India acceded to the Antarctic Treaty System in 1983 and established its first manned permanent research base at Dashin-Gangodari in Antarctica. Our country also attained consultative status in 1983, one among the 25 nations then. Later, India became a member of Council of Managers and National Antarctic Programs, Standing Committee on Antarctic Logistics and Operations, Commission for the Conservation of Antarctic Marine Living Resources, Scientific Committee for Antarctic Research, Committee on Environment Protection. Further, in 1988, Maitri, India's second manned permanent station, was established in Shimachur Oasis, Central Drowning Moorland, Antarctica, which could accommodate about 60 expedition members. Dashin-Gangodari got buried in ice subsequently and abandoned in 1990-91. Later, a new Indian base, Bharati, was commissioned at about 300 kilometers east of Maitri on 18th March 2012, with a capacity to accommodate 72 personnel. Scientists with keen interest in polar science for over 40 institutions, universities, research laboratories, government departments, and so on, have been participating in Antarctic expedition since 1981. But I observed there was no coordination among the diverse research activities. There were avoidable duplications. Moreover, a system to monitor, review, guide the Antarctic research was also missing. In 1995, I appointed a National Expert Committee on Antarctic Research under the chairmanship of Dr. U.R. Rao, former Secretary, Department of Space, with senior scientists and directors of laboratories engaged in polar science as members, with the objective to review the Antarctic research in the country, identify a program profile for the coming decade, evolve a system, procedure, and strategy to coordinate, monitor, review, and guide the activities. The expert committee submitted its report in early 1996, and its recommendations were implemented following due procedures. The Indian program, Antarctic program, then included atmospheric science, biological science, earth science, glaciology, environmental science, health, human physiology, and medicine. DOD organized Antarctic expedition, as I said, since 1981. In addition, 27th December 1995, DOD launched the first Antarctic krill expedition from Kochi harbor in our own vessel, Sagar Sampada, with the guidance and assistance of Sea Fisheries Institute of Poland. Dr. M.R.K. Nair, director of the Integrated Fisheries Project, Kochi, was the cruise leader, which included 3 specialists from Poland: polar navigation, krill harvest, and post-harvest technologies. After successful completion of the mission, Sagar Sampada returned to Kochi harbor on the 10th of March 1996 with Antarctic krill catch of about 5 tons, which were used for the development of krill products and biochemical and processing studies. From the first krill expedition, it emerged that high investment cost, operational cost, high fluoride content in the shell of the krill need to be resolved before commercial operations. Every Antarctic expedition had two groups of scientists, the summer group of about 25 and the winter group of about 10. This is in addition to the logistic personnel catering to the station maintenance, life support system, communication, and associated activities. DOD used to charter an icebreaker class vessel for about 100 days to take the scientists from Goa to Antarctica and bring them back, leaving behind in Antarctica the winter group and picking up the winter group of the previous expedition. I observed that an average 40 days were spent on board the vessel for travel both ways. During the period, very little research could be carried out. In consultation with my colleagues in NCPOR, Dr. Pandey and Dr. Mitra and Dr. Sampath from headquarters, I examined the possibility of reducing the travel time by launching the expedition to Antarctica from Cape Town instead of Goa. I interacted with other authorities of South African government and South African National Antarctic Expedition. I also visited Cape Town with my colleagues to finalize the infrastructure and logistic requirement. All guidance and support were given by the South African government. With the approval of our government, Dr. Pandey, Director NCPOR, then flagged off the first Indian Antarctic expedition from Cape Town on 9th December 1999. Since then, the annual Indian Antarctic expeditions are launched regularly from Cape Town. Thus, there is saving in expenditure and saving in travel time. In 1988, India established the Antarctic Study Center as an attached office of the department in Vasco-Da-Gama, Goa, with a minimum staff of DOD. Mr. Bhaskar Rao was the head of the Antarctic Studies Center. Joint Secretary Administration DOD and Director NIO guided him in organizing every expedition. Though the Expenditure Finance Committee of the department had approved Antarctic Studies Center as an autonomous institute of the DOD in June 1998 itself, Antarctic Studies Center had been functioning as an attached office of DOD for many years. Recognizing the need for autonomous institute in DOD, I renamed Antarctic Studies Center as the National Center for Antarctic and Ocean Research and registered it as an autonomous society under the Societies Registration Act of Goa on 25th May 1998. The government of Goa had allotted about 14 hectares of land at Headland Sada, Vasco, to establish a full-fledged center for Antarctic research. This place was a garbage dumping one for the Vasco municipality. We faced difficulty to stop the garbage dumping till it became a legal issue and favorable orders were received by the court. DOD took over the responsibility of all construction activities from NIO and fenced the entire area and constructed the building and facilities for the research. The NCPOR had built the number of buildings as you are seeing it, and it commissioned the state-of-the-art ultra-clean ice core laboratory, which was commissioned in January 2005, with ice core storage at minus 20 degrees Celsius and processing facilities at minus 15 degrees Celsius. NCPOR established a number of facilities for polar and ocean research, which includes environmental studies, cryosphere, and ice core studies, remote sensing, micropaleontology, paleoclimatology, polar biology, oceanography, marine geophysics, hydrothermal studies, and so on. Dr. P.C. Pandey, a senior scientist from Space Application Center of ISRO, Ahmedabad, was appointed as Director NCPOR on 12th May 1997. He was mainly responsible in building the world-class infrastructure for polar research and logistics. He was supported by efficient scientists, Dr. A. Mitra, Dr. S. Rajan, Dr. M. Sudhakar, Dr. N. Kere, and Sampath from ISRO headquarters. All of them except Sampath are present here. The Antarctic study continued coordinating the Antarctic expedition for about 17 years until NCPOR was established at an autonomous R&D center of DOD. NCPOR was formally inaugurated and dedicated to the nation on 5th April 2000 by Dr. Murali Manohar Joshi, the Minister for Ocean Department, Science and Technology, and Human Resource Development. As Secretary DOD, I represent India in all Antarctic Treaty consultative meetings. During one of the ATCMs in Norway, I held discussions with the Norwegian Polar Institute about the possibility of India initiating studies in the field of Arctic microbiology, atmospheric sciences, and geology at the International Arctic Research Facilities, Ny-Ålesund, in Norway. The response was very positive. In 2007, I was delighted to learn that the dialogues between India and Norway progressed successfully, and India embarked on long-term program on regular scientific activities in the Arctic region. To facilitate Arctic activities, India had taken a station building named Himadri on lease at Ny-Ålesund. Himadri was inaugurated by Honorable Minister for Earth Science, Mr. Kapil Sibal, on 1st July 2008 in the presence of dignitaries from Norway, Germany, and other nations who were working in Ny-Ålesund. In 2018, NCPOR was again renamed as National Center for Polar and Ocean Research, NCPOR, recognizing its scientific pursuits in both Arctic and Antarctic regions. Thus, NCPOR was born. Today morning you heard from the Director NCPOR how it has grown and what their plans are. I conclude by thanking the Secretary MOS, Director NCPOR, and the organizers of this celebration for the opportunity given to me for participation in this Silver Jubilee celebration and talk about NCPOR and later NCPOR. I wish and pray that the Almighty bless and guide all the programs of NCPOR and everyone associated with them. Thank you.
Thank you so much, sir, for taking the journey, how the DOD is involved and making the NCPOR and to NCPOR. So I have a deep apology for wrongly citing his achievement, whatever the sir has done. So I'll again recite for the knowledge of the audience, the sitting here. So as we said that Dr. Muthu Naigam sir is known father for the propulsion technology in the Indian space program. A distinguished space scientist, renowned for his pivotal contribution in Indian space and oceanography, for the creation of Liquid Propulsion System Center. Former the Secretary of Department of Ocean Development, he significantly contributed to the Indian oceanographic research and development. Chairman of the Regional Committee for the Intergovernmental Oceanographic Commission for the Central Indian Ocean, 1996 to 2001. For the Chairman Commission of Conservation of Antarctic Marine Living Resources for 2 years, and the Vice Chairman of the Intergovernmental Oceanographic Commission, IOC, for the 2 years, another 2 years from the 1996 to 1998. He has several accolades in his life career, and this, the main, which is the Aryabhat Award in 2010, ISRO Outstanding Achievement Award in 2008, National Award for the Lifetime Achievement on Ocean Science and Technology in 2007, Mechanical Engineering Designing Award in 1995, and V.M. Gadge Award in 1989. So this is the commendable achievement. So I'll really apologize, and we need at least to give a big applause for sir's achievement.
Stand up and
Yeah.
applaud him as a standing ovation to Doctor.
जैसा कि सर ने, सुधाकर सर ने बोला, सर आपका जो आप लोगों ने बहुमूल्य समय और ज्ञानवर्धक संबोधन दिया है हम लोगों के लिए, मैं हृदय से आपका आभार व्यक्त करता हूं। इसी भावनाओं को व्यक्त करने के लिए मैं कुछ पंक्ति कहना चाहता हूं। अभी तो मंजिल पाना बाकी है, अभी तो मंजिल पाना बाकी है, अभी तो इरादों का इम्तिहान बाकी है, अभी तोली है मुट्ठी भर जमीन, अभी तोलना आसमान बाकी है। तो सर के लिए मैं फिर से एक बार तालियां बजाना चाहता हूं। So, you know, when the ground shakes, and most of us thoughts is the act of God, but science tells different stories. And if anyone has dedicated their life to understand how the earth moves, it's none other than Dr. Padma Shri Dr. Harsh K. Gupta sir. Today we have a privilege to hearing from a man whose work for the transformed how we predict and respond to seismic events. He was the leader of the 3rd Indian Antarctic expedition to Antarctica, and the team established the Dakshin Gangotri as a permanent Indian station at Antarctica in 1983 to 84. Reportedly, in record of time, sir is a globally renowned geophysicist who pioneering the research on the reservoir triggering seismicity, including the well-known Koyna Dam case. He has played the leadership role as a director of NGRI and secretary of the Department of Ocean Development, shaping policies and have strengthened the Indian ocean and polar research. Following in 2004 Indian ocean tsunami, he was the instrumental in establishing the Indian early warning tsunami system, positioning the countries as a global leader in disaster preparedness. He has more than 250 research papers, 20 books, and prestigious honors, and the many more like Padma Shri, has Arthur L. de medals, and contribution to the geophysics and ocean science is unparalleled against him. Today we look forward to insight of the Indian role on polar explorations and legal continental shelf claim, and where the expertise are reinforced Indian scientific and strategic presence. I'll request Gupta sir, please.
A very good morning to all of you, and so happy for this occasion. I'll take a minute's time and I'll invite the Director of NCPOR to the stage. I want to present him a book, Not a Day Different, My Life in Earth Sciences. And it's such a pleasure. Thank you so much. Well, Dr. Muthu Nagan has given a wonderful background to what I'm going to talk. He talked about how NCPOR was created, how it was thought very important to have a center here, and which has done a wonderful job. And my talk will focus on two major issues. One, setting up of the center, the Dakshin Gangotri, in a record time of one Antarctic summer during 1983-84, a record which was made in that year, which remains unbroken even today, after 40 years of creation of that record. And this is just a reminder, most of you know it, but there are some youngsters. So Antarctica is a unique planet, a unique continent with 40 million square kilometers. It is the 5th largest continent. It has got a massive ice sheet with an average thickness of about 1,800 meters. We still do not know whether we have drilled the deepest part or not, but a thickness of 4,780 meters has been seen. And this enormous ice sheet has depressed the continent by about 600 meters. Highest continent with an average elevation of 2,500 meters. You know, we go to stations, for summers, Mussoorie, Nainital, etc. They are all about 2 kilometers or less, but here we are talking of 5 kilometer average elevation. And it is surprisingly the driest continent with the average rainfall of only about 10 centimeters. And there are areas in the interior of Antarctica where it hasn't rained for thousands of years. It possesses very large amount of minerals, resources. The largest coal belt is in the Trans-Antarctic Mountains, which runs to almost 2,500 kilometers. And there is too much of oil and gas, etc. Summer population increases to about 6,000. In winter, it drops to 4,500. There are about 70 wintering stations. This number might have changed. This is a figure which I figured out about a year ago. Now, very early, people started going to Antarctica for sealing and whaling. And many countries took leading part, and several countries put territorial claims in Antarctica. This part is ours, this part is ours, etc., etc. Through the wisdom of International Geophysical Community, we had the 1957-58 as the International Geophysical Year, and there it was decided and agreed to that Antarctica is a place for peace and also for making scientific researches. There should be no territorial claim. All the territorial claims are frozen, and Antarctica Treaty was signed on 1st of December 1959 by 12 nations. Now, India was very keen to be a part of this multilateral global forum, and a decision was made of India's presence in Antarctica somewhere in 1970s. And this resulted in the first expedition led by Dr. Zahur Qasim. In 1981, he went on Polar Circle, a Norwegian ship. They went to Antarctica and they surveyed a lot and came back. Second expedition was led by Dr. Raina from Geological Survey of India. And they stayed there a little longer, but all of them would come back to the ship to sleep, because Antarctica, it was not possible to sleep. So that is where, during 1982, I moved from Hyderabad to Trivandrum, I'm happy that the NCPOR director is here. And in 1983, there was a call for proposals to be submitted for doing research in Antarctica during the third expedition. Being a seismologist, I made an offer. Just give me a glass of water. During, I had realized that Antarctica doesn't have adequate knowledge of earthquakes because there were no seismic stations operating there. So I made a proposal to set up 5 seismic stations in Antarctica, and this proposal was sent to Department of Ocean Development, and somewhere later in 1983, I got a call to make a presentation. So I went to Delhi. That time Department of Ocean Development was located in the South Block, and Dr. Zahur Qasim was the secretary. So I made the presentation. They liked the presentation, but they said that this year we are thinking of setting up the permanent base, and in those days everything was manual. So for those 5 stations, I needed 5 people to man them. So they said, we may not be able to provide you the manpower, so we like your proposal, but we may not be able to support it. When I was leaving that room, they said, but please wait. Don't leave. After all the presentations are over, we would like to talk to you. So when all the presentations were over, I went in, I was called in, and they said that, of course, we have not liked, or we are not approving your proposal, but we offer you to be the leader of this expedition. Will you accept it? This is a challenge which I loved. I said, of course. I took the necessary permissions from the government of Kerala, because at that time, Center for Science Studies was under state government of Kerala. Although we were observing all the rules and regulations which were similar to a CSR autonomous institution. So I communicated my approval to Dr. Qasim, and he said, next day you should come to my office. I went to see him in his office, and he set up a appointment with the Prime Minister. Those days it was easy to go, not so much difficult, because things were much simpler. So we met the Prime Minister, and she was very keen to set up a permanent base that year itself. And Dr. Qasim rightly had some hesitation, because we had been there only 2 years. Anyway, the discussion was going on, so suddenly she turns to me, do you have an opinion? I was totally novice. I knew nothing about Antarctica, just a little bit. But I have never said no to anything. I said, man, give me some time. I was told that come next week, same time, same place. And Dr. Qasim shouted at me on way back home, because why the hell you had to tell? I said, sir, if a question is asked, I have to respond to it. So already DOD was almost ready to set it up, but there was some. So that 1 week I spent all that time with the Soviet Union embassy. They had long-standing stations, and I learned a lot of things from them. There were 2 major things. One was that you should be very careful about the fast ice on which, when we land, we try to unload things. And if you do not test that fast ice properly, they showed me a small film where they had unloaded a piston bully which just sank. So it is very important that the hold of the ship, you should know what is where. Whatever is required first should be loaded in the last. Because they also told me about one expedition which just came back, because the things they needed was in the bottom of the hold of the ship, and they could not unload the entire ship on the fast ice. So, and the British Antarctic Survey was also equally helpful, and the only thing they told us that although the summer months in Antarctica are 2 months, 60 days, out of 60 days, almost half days are lost in whiteouts and the storms, blizzards. So you must plan to do everything in 30 days or so. So it could be those things, all the preparations were made, and we had hired Finn Polaris. Finn Polaris came to Goa, and on way it had picked up all the material which was necessary for building the prefabricated station to assemble it. So this picture is just loading of a Mi-8 helicopter into the hold of the ship. And after that, that evening, we were at Hotel Mandovi. It has disappeared. I was very disappointed to see that. I called Dr. Major Nair, who was in charge of construction, and he came from Corps of Engineers. So Nair had been collecting all the material, so I asked him that, do you please tell me what is where in the ship? He broadly had the idea. Then I narrated the two stories to him, and it was decided that ship should be unloaded and loaded against. On that same morning, Dr. Qasim had introduced me to the captain of the ship and said, from now onwards, whatever Dr. Gupta tells is to be done, is the last word. So next day morning we went and we got the ship, unloaded. It was an 80 feet deep hold. It had 1,000 tons of material, which was a construction material. And when Dr. Qasim came, he was very young. He said, why all this has happened? So the captain of the ship pointed his finger to me and said that he asked. So then I took him aside and told him that why it was necessary, and of course he was convinced. In the process, we were delayed by 3 days. But that was fine, so we left on 3rd of December. On way to Antarctica, we used to have meetings in the morning. One meeting was of the technical groups, science group, other was the logistics. In logistics, we kept on working to bring down the construction activity to 30 days from 60 days. For example, 1 week's time was kept for reconnaissance, which I kept down to one afternoon because the area was more or less known and we had aerial photographs. So I said, I'll go with few of you and then have a look at it, whether it's good or not. I'm not telling many other stories, just basics of it. So finally, we landed in Antarctica on 24th December, 1983. And this is the base camp. These are Arctic tents, 2-man tents in which we used to sleep. And you get into a sleeping bag and you sleep there. Sometimes the sleeping bag is frozen stiff. Somebody has to unzip you. So interesting things. Also, when the blizzard is there, you cannot see anything. So you tie up yourself with a rope and you go out for a call of nature, because otherwise how will you get back to your tent? So those are the interesting things. And then what was happening, that we had pre-bound packages which the Mi-8 helicopter will carry. And as you can see in this picture, it is carrying the load, and if the load generates an oscillation because of inadequate acceleration of the flight, it will be hazardous. So the fuselage of the helicopter was cut and a visible transparent plastic window was fixed so that the flight engineer can see whether the helicopter is moving appropriately or not and keep on advising. On 3rd day, we had a helicopter accident. The helicopter did not gain adequate height. The underslung load got stuck with the railing of the ship. It pulled the helicopter and the helicopter crashed. While going from Goa to Antarctica, there was a room available to me about 30 by 20 feet, and the scientists wanted to put some scientific equipment there. But the doctors, 3 doctors from the 3 services, Army, Navy, and Air Force, they told me that the facilities are not adequate on the ship. And we have got everything to set up a hospital in Antarctica, so please give us a place to do that. The scientists wanted to deploy some equipment in that room, which I gave to the doctors, and scientists were very angry with me. They were saying, sir, आप तो scientist हो, हमारा काम नहीं कर रहे, हमारा ख्याल नहीं रख रहे. मैंने कहा इस वक्त बहुत ज़रूरी है कि हमारे पास medical facilities हों. So when this helicopter crashed, but for that plexiglass window, people could not have come out because it had turned turtle. So we launched a alert helicopter to pick up those people who were there. And at the same time, a rescue boat was also sent. But as you would understand, by the time they reached, they had sunk. This is a little earlier photograph. And they were lifted and carried, 2 of them. Halfway through to the ship, one fell, then the second person fell. It was very lucky that the helicopter did not fall on the ship. Had it fallen on the ship, there was all the oil tanks there, because to serve the wintering party. There could have been fire or something like that. had it crashed on the ice, then also people would have killed. So they came out, and I had alerted the doctors. So if we did not have that hospital with us, they could not be taken care of. So they were taken care of, and then I had to come, and that time the total communication was from the bridge of the ship. So I called Dr. Qasim and told him what has happened. And then he said that the Prime Minister needs to be informed. And I didn't have to do anything. Within few minutes, there was a call from Prime Minister. And I was very surprised. Prime Minister herself was on the phone. And she said, Harsh, is everything all right? I told what has happened. Then she said, are they safe? I said, hypothermia has been setting, but I hope we will be able to get out of it. Her next question was, can you still do it? Somehow I said that if I don't do it, I don't come back. And then there was a very long pause, a 30-second pause, which I analyzed later. And that was a deafening pause. Because a 40-year-old man is saying that if I don't do it, I don't come back. But the Prime Minister has to take a call, has to have a confidence, because after this accident, if something more goes wrong, everyone says that why did you permit them to continue? You should have called them back. And after that pause, she said, go ahead and do it. And that became a war cry for the people. I went to the base station, base camp, called everyone, told every story, and there was a war cry, we shall do it. And from that point onward, the work started on war footing. I had to switch off generators at 10 p.m. because it's all light at that time. The sun does not set in the month of December. So if I don't switch off the generators, people will not stop working. Every scientist, when not involved with the scientific work, contributed to the construction. Here I'm showing the laying of the raft foundation, because we are building that station on ice, and there can be differential settling. So you have to provide a common base. So this was a raft foundation, which covered the 620 square meter of the station area. And you can see people working on that. So you have to dig ice for about 2 meters, and then put this foundation, and the structure starts. So one of the proudest moments of my life, as I told yesterday, was 26th of January 1984, when I hoisted the flag. Everyone said that the construction is not possible, but people worked very hard. There were a lot of problems. One of the problems was cold injuries. People will get cold injury, and I'll send those people who had cold injury to the ship, and I'll get somebody else on their place, in this place. After some time, cold injuries were not reported, so I took for granted that people have learned how to take care of cold injuries. So finally, the station was set up, and it so happened that the captain of the ship had told me that we must depart on 1st of March. On 25th of February, he had told it to me. And then again the question that how do I decide if I leave these people behind, whether they will survive the winters or not. So again called Dr. Qasim, and he said, you are at the spot, so you have to take a decision. So to my good luck, on 26th of February, we had a very big blizzard, which lasted for almost 2 days, 3 days. And it exceeded the maximum blizzard reported from that part. So that gave us the confidence that we could leave that station, them behind. And then I thanked my stars that it was 1984. It was a leap year, so February had 29 days. So on 29th February, everything was done, transferring, etc., and we left. So on way back on the ship, I found that some of my colleagues had lost their toes. And I said, what the hell, why didn't you tell me? Sir, if we told you, you will send us to the ship, but we wanted to work there. That really made me cry. So when I look back, so creation of the station in Antarctica in 30 days, in one Antarctic summer, was not done till then, has not been done since, and it was populated. So when I look at it, that what made this miracle happen? So excellent preparatory introduction, unloading and reloading of the ship, plexiglass window, allotment of 2 rooms to the medical facility, helicopter crash. Because that helicopter crash really inspired us. And actually the book that I've done, Not a Day Different, is the kind of instances that have happened to me in my life, which we thought to be horrible, they turned out to be a blessing in disguise. So I personally feel that that helicopter crash was one single factor which grew us and propagated us to do this job. Then lifting of the query after the helicopter crash, Air Force wanted to have a query, so I sent a message to the PMO office that if I get busy with the query, there'll be no time to construct the station. It was lifted. A very strong blizzard that we had in the last week. Colleagues having cold is not burning. Hard committed work of 81 members, support from Phil Polaris. And look at that station, 620 square meter of raft foundation with living space for 12 generators, laboratories, melt tank, heating, medical room, gymnasium, etc., all done in 30 days' time. So it is just a miracle. So that is how I looked like at that time, as I am in the cabin. And in 2005, I went to Antarctica again. Pandeyji was there. And Kapil Sibal wanted to visit Antarctica, and he was taken there. By that time, Dakshin Gangotri was under 7 or 10 feet of ice. And I got very moved, so this is what I'm lying on Dakshin Gangotri, where it was. I'm now going to legal continental, and it's such a pleasure to give this talk when Dr. Pandey is here and Rajan is here, because Rajan is the architect of this whole program. So this is just, you all know what is our exclusive economic zone, what are the high seas, and what is the continental shelf, what are the deep ocean flow, and the exclusive economic zone, and the concept of legal continental shelf, and process of delineation. Actually, Rajan has written a wonderful editorial, so I've taken all this material from that with his permission. So ratification of UNCLOS was done in 1995. One of the first hugely successful DoD MOS project was to delineate the outer limits of Indian continental shelf. And what was done? In 2002 to 2004, a program led by NCPOR, NIO, and NGRI. And there were about 40 scientists from 7 institutions, but major from these 3 institutions. So they covered 31,000 line kilometers of multi-channel seismic reflection data, bathymetry along the 1242 pre-treatment profiles, 100 ocean bottom seismometer operation, everything done and coordinated by Dr. Rajan. So it all was integrated, all this data, and this was done in just 2 years or 3 years' time at most. So all this was submitted to Department of Ocean Development and then the ministry, and then finally in May 2009, our claim was set. And if you look at the Indian exclusive zone, here I'm showing the 2 areas which has been identified during the legal continental shelf program, which amount to about 0.8 million square kilometer of. So as and when our claims are accepted, India already has an exclusive economic zone of 2 million square kilometer. That will increase almost 40% more. As I was telling yesterday, this would be one of the greatest contributions that any scientific institution has made to the country. And I think Rajan and his colleagues need to be clapped for that. And wonderful things have happened. This is a total solar eclipse in Antarctica, and the architect is again Pandeyji. He made the proposal was accepted, and this was observed. This does not happen every day. I was told that this is a rare event which repeats about 400 years. Then there were multi-wavelength coronal imaging, rare shadow and band observations, thermal response of the terrestrial atmosphere, beautiful Baily's beads, diamond rings brought recognition to Indian Antarctic program. And then this is setup of the ice core laboratory. somewhere in 2005, and you can spot Rahul Mohan, Dr. Pandeyji, Kapil Sibal in this. And what is this? Revealing climate change scenarios, international recognition positions in international committees, outstanding performance since its inception. And then the last thing I'm going to mention is the pilot South Ocean expedition, which was taken up in 2004. And Rahul Mohan, where is he? He's a person who did all this. And today, it's a full program, immense work carried out in the years to come, and there's global recognition and all that. I'll close my talk. Well, it is always a pleasure to be as you are. I'm grateful for this, this invitation to be here. And thanks to all who collaborated for the legal council led by Rajan. Thanks to members of the Third Indian Scientific Expedition to Antarctica and supporters. Thanks to Velat Thamban and Rahul Mohan for this opportunity. Thank you very much for your patient listening.
Thank you so much, sir, for the enlightening the talk and the contributions to the Indian polar exploration and legal continental self-claim have not been the strengthened the scientific presence, but also the reinforce the Indian strategic position in the global arena. NCPOR has been forefront of this effort, and your leadership has a crucial guiding the research and policy domains. And really, on behalf of NCPOR, we express our sincere gratitude and your time, wisdom, and invaluable contribution which we have received. And the way which we have stations in Antarctica, the first is always important because we don't know that climate, how it is going to be act, and what are the challenges we are going the expedition when we started. So it's a really privilege, sir, for that's a very tough time which we have done. तो उस पर मैं एक चीज़ बोलना चाहूँगा, मुश्किलों से भाग जाना आसान होता है, मुश्किलों से भाग जाना आसान होता है, हर पहलू ज़िंदगी का इम्तहान होता है, डरने वाले को मिलता नहीं कुछ ज़िंदगी में, डरने वाले को मिलता नहीं कुछ ज़िंदगी में, लड़ने वालों के सामने आसमान और जहां होता है. So as we celebrate the 25 years of NCPOR, it is essential to recognize the transformation that strengthened the India's earth sciences research, starting with the evolution of Department of Ocean Development into the Ministry of Earth Sciences, MOES. The architect of this transformation was none other than Padma Shri Prem Shankar Goyal sir. Whose leadership helped to integrate the ocean, atmospheric, and geoscience into the unified scientific vision. An Indian space scientist, former Secretary of DOD, former Director of Indian Space Organization, P.S. Goyal sir has transformed DOD into the Ministry of Earth Sciences by integrating the ocean, atmosphere, geoscience, and technology. He was the first chairman of Earth Commission. He oversaw the commissioning of tsunami warning system of India, initiated the modernization of IMD, and pursued the exploration of deep ocean. He is the honorary distinguished professor at ISRO and holds the Professor G.K. Menon DRDO chair. Dr. Goyal sir has been recognized both home and abroad for his work and his contribution towards the development of satellite technology. He has initiated the research and development satellite control systems and guiding the country's space program for the decades. He has contributed significantly into the development of altitude control system, mission planning for the remote sensing, communication, and the scientific mission. He has been the recipient of many awards which has been the Padma Shri, Vizavik in Industrial Research, Prakash Vasin Award, ISRO Special Achievement, Vikram Sarabhai Awards, then many more has Vanna sir. So today we have a privilege for hearing the insight from the revolution of bloom of chloral exploration. Please join and welcoming with the, thank you so much, sir.
Well, thank you very much. Good afternoon to all of you. You have heard the story about Department of Ocean Development. I was asked by Dr. Thamban that I should be talking about the transformation to Ministry of Earth Science. So one advantage I have is, if you feel bored, don't blame me, blame him. The starting point is something different than what the story you have heard about the DOD, because DOD has evolved over this 4 or 5 generations, starting from Dr. Qasim to all the way up to Dr. Harsh Gupta. Now, when we look at the genesis of our sciences, it's all, I just want to do this brief you, so we'll go to the next. It just happened in one of the SECC Scientific Advisory Committee meeting. Dr. Harsh Gupta asked me in 2005, I think it was February 2005, and he said that I am being superannuating in June. Would you like to come as a Secretary DOD? I was that time itself Director of ISRO Satellite Center, never thought, I didn't know what the ocean is. But I said, okay, let me think it over. Professor Narasimha, you have heard about him. He was a very visionary scientist. He just expired a few years back. He came to me in May 2005 and said, you will be offered Secretary of DOD, Department of Ocean Development. Please accept it. And then he said, why? So he actually told me all that about, I didn't know anything about the integration of what the ocean has to do with the atmosphere, what the atmosphere has to do with the ocean. And he said, we want to create a Ministry of Earth Science, and you only can do it, and we need you. Somehow, he was my teacher in ISC, and I had a high respect for him. And also, I considered Dr. Kasuri Rangan, who was my, you can say, guide, philosopher. And they said, yes, go. It's a chance to do something new. And what brought here was just to do something new. And that's how I just was here. It's not moving. Okay. So when I came here, basically, idea was that you have to integrate ocean and atmosphere. That was the first priority, because Professor Narasimha wanted to improve the forecast of the weather, or maybe to some extent longer forecasts. And he said we have to couple these things. Now, the task per se was essentially difficult because the IMD is dealing with many departments. And of course, it gives advisory to agriculture, it gives advisory to airports and all that. So the Cabinet Secretary linked 14 ministries, and of course including Planning Commission. So he said that we have to convince all those 14 secretaries, including Planning Commission, that they have to agree. And that was a task essentially to give the advantage. So I had to read a lot and take help from our people in the ministry and to work out the presentation. So essentially, that was a goal. And here, again, I always remember a slogan which was given by Professor Sarabhai. He used to tell that advanced technology for man and society. So that was another motion that we thought we have to create this as a ministry of mission mode ministry. Mission means it has to have a task to accomplish. It's not just we are doing for the sake of science or we are just publishing paper. It has to be connected to the people. So that was the motive. And as you know, there was a tsunami in 26 December 2024. In a way, that was helpful because all the decision makers, they were understanding the role what ocean can do because before that, we all read about tsunami in our primary schools. But we had all forgotten, the whole country had forgotten about tsunami because the last tsunami occurred was 1942. So such a large gap, and that too on the other side of of India. So our job was to really integrate that and convince the other one. And here, the 4 units, that means IMD, NCMR of IITM, they were with the Ministry of Science and Technology. Of course, advantage was that we have a common minister. And because of some help from Professor Narasimha and some persuasion, minister agreed for that we will do it. However, the difficulty was our secretary, Dr. Ramurthy, was a very good friend of mine of DST. And I can tell you right now, because the older story, probably he would not mind now. He told me, look, I agree with you the concept. I agree it's the right thing to do. But if I sign on this paper, that means a cabinet has to be signed by the secretary. He said, if I sign on this paper, I will tell myself that I'm a useless person. He said, I have been secretary of DST for last 10.5 years. And if you say, I'm not doing anything because of what I'm doing. So he said, I'm retiring on 30th May. If you want, you move your paper on 1st June. I will not sign this paper till I retire. So actually our cabinet paper was ready in February. But we could not do it because Dr. Ramurthy would not agree. One more thing happened in between, which Dr. Rasik Ravandra reminded me. I had to skip that. Because this was not happening, so I had a little discussion with the Cabinet Secretary. Cabinet Secretary was a good friend of mine because in the Earth Commission, in the Space Commission, I used to be a member earlier for 2-3 years. So we were together. And then we discussed that we'll create the Ministry of Ocean Development. So actually, an order came without any consultation. The DOD became Ministry of Ocean Development. And when this paper came, my first encounter was with the minister, and he said, what you have done? He felt that I am planning to take out the ministry from the Department of Science and Technology and take separately to another minister. So I folded my hands. No, sir, our intention is not that. We are just creating a ministry. It has been created. And I told him that actually just Cabinet Secretary asked me. I have not pursued any paper because there was no paper. It just order came. So that was another story that February 2006, we got Ministry of Ocean Development. Now, the Earth Commission was created, and that was again a very unique thing to happen. We got the cabinet note approved after Dr. Ramurthy retired. Immediately we pursued the paper, and before the new secretary came, Dr. Ramaswamy, in fact, first day I took his signature. He didn't even realize what he's signing for. But he signed. And because of that, on, I think it was actually day was 12th July 2006, when we got our ministry created, Ministry of Earth Science. There was one issue with respect to what should be the foundation day. Ocean Department, we used to have a foundation day on 27th of July. That has been happening right from the very beginning. Now, our whole ministry came and said, sir, we cannot forget the history. So I said, okay, we will keep the, as far as the foundation day is concerned, 27th of July. We still do that, even though actually order came on 16th of July, but these are smaller things. Now, what were the biggest tasks? Actually, if I recall, before creation of the Ministry of Earth Science, all my time, 50 to 60% was going only with NIOT, because there are a lot of things to be done. NIOT was a unit with very small manpower. You can't imagine that there were 36 normal regular engineers, and there are almost 4 times, 120 or so, contract engineers. How can you run a system or make a system with such a huge inverse ratio? In ISRO, I was actually familiar only with the other way. that you have a very small contract manpower and most of the people will be regular. So that was the time. But after creating Ministry of Earth Science, all my time was going only in with respect to the IMD. And I'll tell you there are a lot of stories about that, but maybe a few things will go. But there is very interesting thing about NCOR, because there was NCOR there. We had a very interesting joint secretary. I have not seen such a person in my life again. One day, the joint secretary of CSIR, he came to me, sir, we have created the building of NCOR in Goa. I didn't know that. Actually, the building of NCOR was created by CSIR. I said, yes. He said, sir, we are not getting our payment for last 2 years. I said, what is the problem? You are a government body within the same ministry. He said, no, your money has not been paid. So I called our joint secretary. He said, what happened? At particular that time he was away. So when he came after 2 days, he was on a foreign tour. I asked him, what happened? He said, sir, you give me permission. I want to send Mashelkar into jail. This is a big scam. So it was a shock of my life. I knew Dr. Mashelkar for a long time, and he was a secretary of CSIR, CSIR, almost 11 years. And my joint secretary tells me that he wants to send him jail for the building of NCPOR. In fact, there are various other regions. The joint secretary by itself, we can write a book. We had to send him back on 3rd of September. Send back, and only after that, we made that payment due to CSIR for building creation in NCOR. So that's just for you, for your information, this kind of things we have gone through. And transformation, what it means. See, when we are talking transformation, it requires 2 things. One is require enabling, that means a sort of money, facilities, and manpower. So manpower, as you know, is very difficult. In fact, I would really appreciate that perhaps any manpower increase has taken place anywhere in the science ministries in the country. It's only this ministry, and thanks to Dr. Shailesh Nayak and all other people who have really pursued that. Otherwise, you will find ISRO. The manpower is stagnating from 90s onwards, again 16,000 only. In DRDO, manpower is only 31,000 something, few hundred, right from last 40 years. So manpower increase in scientific department is very, very unique to only Ministry of Earth Science, which you have done. So that's one part. But you just look at the budget. Before that, our DOD budget for 5 years was 1125 crore. But because we wanted to modernize, we got the allocation of 7,500 crore. And out of that 2,500 crore was only for modernization of IMD. So that's a kind of a transformation. And this transformation, when it started, I'm happy to say that it has continued all along, all the successors in the Ministry of Earth Science. Similarly, there is a story about the Sagar Nidhi. Within 15 days, I got a file of Sagar Nidhi telling that this particular ship file has to be scrapped. And I think Ajay will remember that when this file came, there was some specification in the quotation which it was not meeting. And you know, always in any equipment, you can have primary specification and there is secondary specification. And the ministry, the finance people had written that this particular file has to be scrapped. I discovered that in the period of 2 years, the steel price had gone from 22,000 per ton to 43,000 per ton. That means if you re-quote it, the price will go at least twice. And so that was one thing which I overruled all the finance ministry, gave approval, and I think that's because of you have the Sagar Nidhi. We couldn't do such thing for the, let's say, icebreaker. Otherwise, we could have got icebreaker also by this time. So these are the things we have gone. Very important thing is that the Earth Commission, which was created with the presence of the Cabinet Secretary, Secretary to the Prime Minister, that worked very well. And in the history of India, out of 4 Earth Commission meetings in the first 1.5 years, two were held in the Prime Minister's office. It has never happened. Space Commission or Atomic Energy Commission, never in the PMO. Because our relation with at that time with the PMO was so good. That's why you got all that money. And in fact, few things like, when Dr. Shailesh Nayak, actually I pulled him from SAG to as the director of inquiries, and he was coordinating all the activities with respect to development of our tsunami warning system as well as earthquake information. So Cabinet Secretary, when they called me, if there is any earthquake in the country, I should be the first person to know. I didn't know. I said, we'll do it, sir. Actually, I had his number. Second day, I got the same call from the Principal Secretary of the Prime Minister. I should be the first person to know. Then I realized that there's a competition who should tell the Prime Minister first that the earthquake has happened. So that's the kind of role actually which was given to our ministry. Okay, essentially, I'm just not getting these are all the aspects one has to go. But when it comes to the, let's say, NCOR, you remember when I took over, Dr. Pandey was just about to retire. Now, NCOR was basic in the sense because the DOD evolved along with the NCOR. Now, there is an interesting story about Dr. Rasik Ravindra's appointment. We gave a advertisement and he joined. He was actually with the GSI, there is a wing, separate marine wing, and he is the only person who had gone to, that time, I think 3 times earlier before he has gone, or 4 times, I don't remember. So when we had the interviews and all that, he was the clear-cut candidate as a director of NCOR. But there was another person, because the old story I can tell you today. This is when Dr. Naqvi in NIO. He was also appearing. And Dr. Naqvi was a fellow of INSA. He had at least such a big, thick publications. So he complained to our minister, Kapil Sibal, and he said that this selection is not right. Kapil Sibal called me. He said, look, how can you select Rasik Ravindra, whose scientific stature is nowhere near Kafi? I said, yes, sir, I agree with you. I'm not looking for the best scientist. I'm looking for the best director. So I convinced him, and that proved the dedication which Rasik Ravindra had here, and actually convincing me at least, that we should be present in Antarctic also. It was all because of his pursuance. So we're going to, let's say, Norway, taking a minister there. Of course, the first thing which was very interesting in Norway was that there was a very big statue of Mahatma Gandhi. It was there. So there was a very interesting thing to see there. But convincing Norway people was much easier than convincing our own finance people. However, all things happened, and today, I think it's because of that initiative at that time that NCOR has become NPOR. So I think we must give thanks to that. With a few things like, one advantage we show to the government for this, that if we create ground stations in either South Pole or North Pole, or both, the advantage is that normally our remote sensing satellites have a visibility of about 4 orbits a year out of 15. But if we go to North Pole or South Pole, our visibility increases to something like 11 to 12 orbits. So there is a big gain, particularly when you are looking for the data and all the time collecting from there. So we could create a station, we could create even, let's say, windmill there at the wind turbine or wind energy. So all this has happened, and that journey for creating a Ministry of Science, I think is well known, but I just want to tell you a few things. Now, but when you look at for the future, I personally feel that we have to have our own icebreaker, but not just own. See, I want to tell you very frankly, after 5-10 years, if another Prime Minister comes like Modi ji, he will ask you, you are doing good science. And certainly you are doing good science, and you will be doing good science. But whether good science will be good enough? That's a question always lingers in my mind. So you have to connect in addition to what we are doing in the Ministry of Science elsewhere, whether IMD or NIOT and all that, even at NPOR, you have to bring connection. And one thing could be, can those technologies which you are using, let's say, can we create an icebreaker in India? Why don't give the challenge? It can be done. We have the capability today, but someone has to take a lead. So not only we should own an icebreaker, we should create an icebreaker technology capability in India. That you can take. If you do that, that will be a very good thing. Then, of course, you know, I was just thinking that we use all those gadgets, including sunglasses. We import actually from for going to Antarctic, or the clothings, or the preserving foods, or generally, let's say creating lots of new crops in the ice region. Can those technologies, which the Russians showed us they were doing, can we not give it to our armed forces who are working in Himalayas in the very cold regions? In fact, there is an institute in Leh, DRDO. They are doing some of these technologies. Can we bring those technologies and bring our relevance to the society, to our people? This is something which you have to think of. So idea is that we have to really think how we can be a little more useful. Whether Himalayan technology, can we, if you look at whatever goes, instrumentation, we all import. Can we become a agent for development of those things? So this is what I'm just trying to say. You have to think further, how do you connect also to the society, to the people? This will be something very important. I thought that's the only message I can give as far as you are concerned. Otherwise, science-wise, you are doing a good job. Continue to do that, and best of luck. Thank you very much.
Thank you so much, sir, for taking us through the incredible journey of the transformation. Your vision has not only shaped the MOES, but also strengthened our institution like NCPOR. And giving the solid foundation for your leadership, the legacy of your leadership continue inspiring the generations of the scientists. We're truly grateful for your contributions for the Indian scientific progress. On behalf of NCPOR, we extend the deepest appreciations and the time to insight for the today. So I'll request everyone to have a big round of applause for the sir. So now I'll request Dr. Rajivan sir, and I'll request Dr. Thamman Milot sir to please join the dais. So now it is a time of appreciation. It's a very rare occasion in the history, and especially for the NCPOR, it's happened. We have among us all the secretaries who was involved in the forming of NCOR to NCPOR. So it is our honor and privilege behalf of NCPOR. I'll request Shailesh Nayak sir to please give a honor and felicitate the today's dignitaries. Dr. Muthu Naikam sir. I'll request all the dignitaries, please, if you can come front. So it will be a great opportunity for us to capture the photographs today. So I'll request director only to please felicitate all the dignitaries. Okay. तालियां बजती रहनी चाहिए, समय है। So now I'll request our director, for the Harsh Gupta sir. I'll request our director to Dr. P.S. Goel, sir. It's a great honor. I think we should not stop our. Now I'll request Director to Dr. M. Rajivan, sir. I could pronounce it perfectly now. I'll request Director to at least.
I want to add, again, I want to say this. It is a rest of the occasion to have all the secretaries of DOD as well as MOEs on the same stage. So it is important that the standing ovation again.
We break for lunch and we hope to be here by 2:45. I don't think 2:30 everybody can be here. To 2:45. Acha, okay. You cannot finish. Okay, 2:30.